All right, we've got one last problem. This will wrap us up not only for the section, but also for the whole topic as well. And like I said in the previous video, this example right here is a titration problem, but it's kind of a challenge problem. It really takes some out-of-the-box thinking a little bit. So let's walk through this one together. The question asks, what is the molar mass of a binary diproduct acid if 30.5 milliliters of 0.1112 molar sodium hydroxide is required to neutralize a 0.1365 gram sample? And then what is the acid? So you're like, oh God, that's different. This happens in chemistry sometimes, right? You get a problem and you're like, oh my gosh, this just sounds like it's so difficult and it's hard and there's no way I could possibly do it. And while it might be true that maybe some of you won't be able to get all the way through it, you'd actually be surprised how much you can figure out on your own if you just take it step by step. Okay, and so when I look at this problem, the first thing I realize, even though I may not know what all of that stuff means, I see that I'm reacting an acid with a base, right? And so the first thing I would recommend doing is write out a chemical equation. Now you may be sitting here thinking, how can I possibly write a chemical equation? I don't even know what the acid is. It's unknown. You can actually write more than you think you can if you just give it a try. So let's do that together. And I'm going to actually, just to save some space, I'll do that up at the top here. Okay, so you have sodium hydroxide. You know the base is. Okay, so it's sodium hydroxide. Now it's reacting with an acid. You don't know what the acid is. Now you do know acids always begin with hydrogen, right? So you've got at least that. Now it tells you that the acid that we're looking at is a binary diproduct acid. So let's remind ourselves what those vocab terms mean. When you have a binary acid, or a binary compound in general, what that means is it's two elements. Not necessarily two atoms, but two elements are bonded together. Well, if it's an acid, one of the elements has to be hydrogen. So then the other thing, it's like what's attached to the hydrogen? It's not a polyatomic ion. It has to be just a regular element. So we'll just call it X, right? Maybe it's chlorine or sulfur or bromine, who knows? But it's an element, right? You also know it's a diproduct acid. Remember what diproduct means? It means two hydrogens. So no matter what it is, it's got to be H2X. So even though you don't know what the acid is, you at least know it's going to be H2 something. So now when you think about what the products are, okay, sodium is going to come over here and it's going to bond to X. Okay, so sodium is going to bond to whatever X was. Now, even though you don't know what X is, you don't know what element that is, you do know that X's charge must have been -2. How do I know that? Because apparently it took two hydrogens to cancel it out. So whatever element X is, it must have a charge of -2 because it took two hydrogens to balance it out. So that means when sodium bonds to X, sodium's +1, X is -2. So it must mean that there should be two sodiums there. Whatever X is, there should be two sodiums. And then the other product is hydrogen coming over here, bonding to hydroxide, so it's going to be water. Okay? And so here's your unbalanced equation, and then of course we have to balance it, so we put a 2 here and then a 2 there. So do you notice how even though you have no idea what the acid is, you were actually still able to come up with a balanced chemical equation? Like I said, you may not have known you could do that, but as long as you just keep chipping away at the problem, you'd be surprised at the things you can do. It was necessary to know what binary and diproduct meant, right? So if the problem gives you words like that, there's probably a reason why. Okay, with all that being said, let's get into the math, right? It says, what is the molar mass of this acid? That's ultimately what we're trying to solve for, right? We're trying to solve for what's the molar mass of the acid. Well, what are the units for molar mass? Molar mass are in units of grams per mole, right? And so ultimately, I'm thinking to myself, okay, if I'm trying to solve for what the molar mass is, I need to take the grams of the acid divided by the moles of the acid. If I can do that, then I can solve for what the molar mass is. And that looks like I made up a word, gassed. But little space there. There we go. So if I can take the grams of the acid divided by the moles of the acid, I have my answer. Well, you actually know what the grams of the acid are, right? It gives it to you right here. So the number of grams that I have for the acid is 0.1365. So whatever the acid is, that's the grams of it. I just now need to figure out what's the moles of the acid. And you probably can guess at this point, where are we going to find that out? You're going to find it out from stoichiometry. So you know you have 30.5 milliliters of the base. So 30.5 milliliters of the NaOH. Now, first step of stoichiometry, let's get that converted to moles. I know the molarity of the base, and so for every 1,000 milliliters, there will be 0.1112 moles of the base, the sodium hydroxide. Okay, and then at this step, I want to get out of moles of the base, NaOH, and I want to get into moles of the acid. I have no idea what the acid is, but I know it's H2X. Well, I know what my mole ratio is. For every 2 moles of base, I will need 1 mole of the acid. All right, and so at this point, if I solve, this is going to give me my moles of the acid. So let's take 30.5 times 0.1112, and then divided by 2 and 1,000, so 2,000. I end up getting the number of moles of the acid is 0.00. What is that? 1696 approximately. So that's the moles of the acid. If I put that at the bottom here, 0.001696 moles, then if I divide these two values, I'm going to end up getting my answer in the units of grams per mole, which is the molar mass, right? So 0.1365 divided by 0.001696. Oops, sorry, did a little mistake. 0.1365 divided by 0.001696. There we go. I'm going to end up getting my molarity with 3 sig figs because of the 30.5. My molarity for my unknown acid is 80.5 grams per mole. This is the molarity of my acid. Now, the second part of the question is, what is the acid? You're like, how the heck am I supposed to figure that out? Well, remember, this is the molarity for the general form H2X. So 80.5 grams per mole is 2 hydrogens and then this unknown element. Well, if I subtract out the mass of 2 hydrogens from this, so the mass of 2 hydrogens is about 2.016. So 80.5 minus the mass of those 2 hydrogens, I end up getting the molar mass for just element X is what? 78.48 grams per mole. So at this point, I have to ask myself, what element has a mass of 78.48? And if I take a look at my periodic table, the element that has a mass of 78.48 is selenium. So the actual acid itself is H2SE, okay, or hydroselenic acid. And notice, what did we predict at the very beginning? Remember, we said X had to have a charge of -2 because it took 2 hydrogens to cancel it out, right? Well, selenium is in the group that normally would have a -2, so that actually validates that we did this correctly. So the final answer is 80.5 grams per mole is the molar mass for the acid, and the identity of the acid is H2SE. That wraps up section 5 as well as topic 10. We'll see you in the next topic.